I want to bring you into a new discovery that we made today. You might remember last week I proposed that maybe the musical scale should actually have 24 notes in it. And I was calling it the 24-note quarter tone chromatic scale because I'd found that 528 hertz in precise temperament tuning and 432 hertz in precise temperament tuning actually made this interweaving, almost like two snakes that are basically weaving into each other like the staff of Hermes, which is kind of interesting because I hadn't even thought that the two would be related like that. But of course, 18 times 24 equals 432, and 22 times 24 equals 528, which is basically then creating a boundary condition around the number 40, which is also what quaternity is based off of. So 4 and 40, again, related. So something very significant there, and I called it the musical wave of time, because then I realized that time itself was related to this kind of construct. So what is it about 24? Well, one of the things that I discovered and published on was that the number 24 relates to every prime number. It also has the Fibonacci pattern embedded within it because in mod 9 analysis, the Fibonacci pattern repeats every 24 numbers into infinity. So with 24, we can also look to see that any prime number greater than 3 squared will give us a multiple of 24, or 24n plus 1, without exception. So we proved this in a paper we wrote called The Infinite and Accurate Prediction of Prime Numbers using the novel quasi-prime methodology. So 5 squared is 25, and that's equal to 24 times 1 plus 1. Okay, 7 squared is 49. That's equal to 24 times 2 plus 1. 11 squared equals 121, which is 24 times 5 plus 1. And 13 squared equals 24 times 7 plus 1. And then 17 squared equals 24 times 12 plus 1. And then 19 squared is 24 times 15 plus 1, and so on. Now, what does this have to do with music? Well, we believe that prime distribution is also related to music. You know, Bernard Riemann wrote the whole prime number distribution thesis that is still yet to be proven. He's more famous for being a musician and someone who wrote music theory in Neo-Riemannian music theory than he probably is even for prime number theory. But clearly there's some relationship to 24ness, and we believe that the geometric structure of that is the cube octahedron. Now, is 360 degrees an arbitrary number? I don't think it is, right? And I've actually written proofs on this too, but let's consider something. First of all, the thing that we have every day is a calendar. And our calendar is very closely aligned to 1 degree equaling 1 day as we traverse around the orbit of the sun. So now let's look at the 360-day year that the Egyptians and the Sumerians used. Now we have a solar calendar and we have a lunar calendar. And the solar calendar is no more important than the lunar calendar. The two are connected to each other, again, just like these two snakes that are creating the quarter tones of the 24-note progression in a chromatic scale in precise temperament tuning. And it sounds really good, by the way. But secondly, we have a lunar calendar as well. So the solar calendar is 365.25636 days for one solar year. And then with the leap year, the average of that comes out to 365.4422 days, right? Now the lunar year comes out to 354.36707, and with the leap year added, it's 354.525 days. So if we now average those two numbers, 365 plus 0.4422 and 354.525, it gives us 719.9672. We divide that by 2 to get the mean value, and that means that we've got 359.9836 days when we equally weight the masculine, the solar calendar, with the feminine, the lunar calendar. So that means that the accuracy of this is pretty astounding. 1 day equals 1.00004 degrees. That's an accuracy of 99.999% accuracy. That's pretty astounding. Now we could say, oh, that's just a coincidence because somebody, sort of threw that in there. I don't think so. And here's why I don't think so. Because the number 360 can also be derived as related to 24. In fact, the number 360 is 24 times 2.4 times 2.4 plus 0.24 divided by 2.4 squared times 2.4. It's a lot of 2.4s, right? What's the significance of that? Well, even pi has a close approximation, much closer than 22 over 7, that's the square root of 10 divided by 10 plus 1 to the power of 1 over 0.24. That's giving us a pi. So there's something really significant here, and it relates back to this perfect triangle. The perfect triangle is a 5, 12, 13 triangle, which could also be expressed as a 10, 24, 26 triangle. And that's the only triangle in 5, 12, 13 that will give you a perimeter and an area that's equivalent of 30. So there's something very significant about this 24. Now there's some other property that relates to 24 that's important, because 4 times 3 times 2 times 1 equals 24, and 4 plus 3 plus 2 plus 1 equals 10. So 1 over 24 is also equivalent to 0.042. It rounds to its palindrome, right? And just moves the decimal position. So there's something very unique here that relates to the Pythagorean tetractys 4, 3, 2, 1, 1, 2, 3, 4, which you've also found in the Giza Plateau. So now, let's look at time. Can we derive time solely through the number 24? Which is really then just another way of looking at, for every time you see the numbers 24 or 2.4 or 0.24, you literally have 1 times 2 times 3 times 4, or 0.1 times 0.2, 0.3, 0.4, right? Same thing. And you've got, for the number of seconds in 1 minute, 24 times 2.4 plus 2.4 equals 60 seconds in 1 minute. So 24 times 2.4 equals 57.6 plus 2.4 equals 60. Then we have the number of seconds in 1 hour. So we take that same 60, and that's derived as the 24 times 2.4 plus 2.4. Multiply that by the same 24 times 2.4 plus 2.4 equals 3,600. That's the number of seconds we have in 1 hour, right? So again, only with 24 and 2.4, you could derive the whole thing, which then you could replace every one of those 2.4s and 24s again with 1 times 2 times 3 times 4. So then you've got 3,600. So now let's find the number of seconds in 1 day. That's going to be 24 times 2.4 plus 2.4 times 24 times 2.4 plus 2.4 times 24 equals 86,400. So that's the number of seconds in 1 day. So then let's look to see what happens for 1/2 month, because we have to cut the year into 24 parts, which then puts us into 15 days. So if we multiply that, 86,400 from here, which was just derived from using this, and we multiply it by 2.4 times 2.4 plus 0.24 divided by 2.4 squared multiplied by 2.4, we now have 1.296 million seconds, which is the exact number of seconds in the compass. Isn't this interesting now? Which that'll become more important in just a moment. We take that same 1.296 million seconds, multiply it by 24 times 2.4 plus 2.4, again times 2.4 times 2.4 plus 2.4 equals 31,104,000 seconds of 1 year. That's the number of seconds in 1 year. And then if we multiply that by 24 times 24 plus 24 divided by 24 times 10 to the third power gives us this number right here, 777,600,000,000. That's the number of sexaseconds in a compass. So if you take each of the compass measurements, start with 360 degrees, multiply the 360 degrees by 60, multiply it again by 60, that's going to give you the total number of seconds in the compass, 1.296 million. Multiply it again by 60, and you've got 77,600,000 number of seconds, sexaseconds in the compass. And what this number is that number multiplied simply by 10 to the fourth power. Okay, now let's talk about dimension. So here we have dimensions. We have the length of a line, right? An x-axis. We have a length. We describe this as the first dimension. It's 6 to the first power times 10 to the 0 power, and that's the length of a line segment. We go to the next dimension. We have another x and y axis now, and we measure that not with length, but rather we measure it with length of both x and y axes, and that gives us an area value. That's how we measure the second dimension. second dimension is measured there. 6 squared times 10 to the first power equals a circle of 360 degrees. So now we have a z-axis that we've added over here. So we've got an x-axis, a y-axis, and now a z-axis. We're going to measure this in volume, units cubed. Third dimension, 6 to the third power times 10 to the second. Notice 10 to the 0, 10 to the first, second, third, fourth, fifth, sixth, and then 1, 2, 3, 4, 5, 6, 7. This is how we define dimensions. In the third dimension, we have 21,600 minutes. That's the number of minutes in a compass. The compass derives for us all dimensional expansions as far as we want to go. That's all based on base 60, which is all derived from the number 24, which is all derived from 1 times 2 times 3 times 4. As simple as that. Then we have 1.296 million seconds in the compass. So that becomes the fourth dimension of time, right, which defines 15 days or 1/24th of the year. And then from there, we go 6 to the fifth power, which would be the fifth dimension, which is then going to be measured no longer in just time, that's going to be one directional time, or what I would call volume in motion. Now we've got a multimodal time, which is two-way multidimensional time. And then eventually, in the sixth dimension, time becomes liquid. Literally like liquid. So you're talking about volumetric measurements here. And 6 to the fifth power times 10 to the fourth power gives us that sexagesimal sexaseconds, right, in the compass. So if we multiply the 1.296 million seconds of the compass by 60 again, you've got 77,760,000, which is the same number as the number of sexaseconds, right, in the compass times 10 to the fourth power, which is the number of seconds in one precessional period of 24,000 years. Then we go to the sixth dimension, which is 6 to the sixth power times 10 to the fifth power, 4.665600000, which is 4,665,600,000. And that basically is giving us the next layer down, right? That's where we get in the seventh dimension. You keep separating out, just like the musical notes here, we're basically adding these quarter tone notes in between. What the compass is actually just a representation, a musical derivation of time-space that is all derived from 1 times 2 times 3 times 4, which is the number 24. 24 is the foundational basis of all that is in prime numbers, music, space, and time.